Okay, today's the day where we're really moving on from, realistically, we just covered 6-1, and that is technically all review. I do understand that at times it was more complicated, but at other times it was not as complicated. Today, we're moving on to entirely new content, and that is going to be rational exponents. Okay, we're going to cover 2 days in this section, and when we do that, we're going to be able to rewrite a rational expression as a root and then determine what that number is. And then I'm going to be able to rewrite a root as a rational expression and then again evaluate. So what do we need to do first is we need to kind of understand the relationships between roots, their squares, their cubes, their fourth powers, and their fifth powers. For example, if I have a root of 0 and I square it, 0 squared means what? 0 times 0. So 0 squared is. Okay. So then if I want to figure out 0 cubed, the root is 0, and I want to cube it. 0 times 0 times 0 is 0. Okay. That's pretty easy, right? Anybody have a guess at the fourth power? Okay. And the guess at the fifth power? Okay. 0 is pretty easy, right? Because no matter what you multiply 0 by, you just continue to get 0. What about 1? What's 1 squared? What's 1 cubed? It's 1 to the fourth power. 1 to the fifth power. Okay, so 0 and 1 are all pretty easy. It's at 2 where things start to, I know, you actually have to think a little bit. Okay, so 2 squared. What is 2 squared? 4. What about 2 to the third power? How do I find that? 2 times 2 times 2. 8. What's the next one? Then? Okay. I know my squares fairly well, so I'm just going to go and finish my squares. So 0. What's 3 squared? 9. 4 squared? Yep. 5 squared? 6 squared? 36. 49. 64. 81. 100. For the most part, I would say at some point, it's just generally beneficial to have your first 10 perfect squares memorized. Okay. Okay, cubes, though, to find the cube, you just go 3 times 3 times 3. But really, that means you can just take the square of 9 and times it by 3 and get 27. But then if I want to find the fourth power, I just take the cube of 20 or cube of 3 and then multiply that by 3. Get 81. And then I can multiply that by 3 and get 243. Okay. All right. So do we think we know how to fill the rest of this out? All right. Go ahead and start working on that. All right, this is what I got. Yeah. Okay. All right, ready? So this is how the chart works. So we're going to use this a lot. Okay. If I ask for 6 to the 4th power, 6 to the 4th power, what number is 6 to the 4th power? 6, here's my root to the 4th power, 1,296. If I ask for 2 to the 5th power, here's 2 to the 5th power, 32. What if I ask for 9 to the 2nd power? 81. So square is 2nd power, cube is 3rd power. All right. Does everybody understand how to use that chart? You go in that direction. Okay. That is not the direction you're going to have to use the chart for. Although it's not going to be harmful to know that. This is the direction you're going to need to do. All right. Ready? The 4th root of 16. The 4th root of 16. What do we think the 4th root of 16 is? No. The 4th root of 16. What do we think that could be? I heard.
Isn't the dividing? Or like
It's not 4. Okay, hold on. Just 1 second. 4 is the square root of 16. I want the 4th root of 16. What is it?
What does that mean?
2. So if I want the 4th root of 16, that means I'm looking for the number you multiply by itself 4 times to give you 16. 2 times 2 times 2 times 2. Let's keep practicing this. Okay, what about the cube root of 343? What number is the cube root of 343? 7. What is the 5th root of 59,049? 9. Because 9 times 9 times 9 times 9 times 9 is 59,000. So that's the direction you're going to use the chart. Does everybody understand that? Okay, now I gave everybody a much more extensive chart than this. It goes all the way to the 8th power. Okay, we're just going to start right off the bat. What I want you to do, okay, is above the 2nd power, I want you to put plus and minus. We'll discuss why here in a minute. Okay. Okay, on a cube, I want you to put plus or minus. Fourth power, I want you to put plus and minus like this. Okay, fifth power. And if you can see the pattern, you can continue that forever. I think Miss Wiggins can attest to my Algebra 2 class, which we're going over similar stuff right now. This plus and minus thing is something that throws people off. So we're going to try to hammer it now. So 2 years from now, you're all going to be golden. Okay. What? Yes, I will re-explain it. Okay. Everybody have that written down? We're not going to use that right this very second, but we are going to in a second. All right. Okay. Let's go ahead. Keep the sheet handy. We're going to use this a lot, the remainder of the chapter. So don't lose that. You'll be allowed to use that on tests as well. Okay, let's go to the next page, 6-2, page 2. Okay, at the top, I have the symbols for the roots. Okay, there are dedicated symbols to indicate that you're trying to find the square root, cube root, etc. Okay, this is cube root. This is fourth root. This is fifth root. Here, there's no number. Technically, that's the square root. Okay. Can you put a little 2 there if you want? Yes. Will you ever see it typed up like that? No. It will never be written like that. Okay. So if there's no number there, you need to understand that it's asking you for the square root of a number. All right. Okay. Ready? So what is this all going to talk about? We're going to get a little complicated here. Is we're going to be looking for the nth root of a. Okay. So what does that mean? N is what root? Are you looking for the fifth root, the fourth root, the seventh root? The a is the number that you're actually looking the root for. Okay. So what I'm going to talk about is mostly this n number. Okay. For the most part, it's got some fairly easy parts. So if n is odd, it has one real nth root. If n is odd, it has one real nth root. And that is going to be plus or minus. It's either going to be a positive number or a negative number. Okay, so hopefully, looking back to the sheet I just did for you, look at all the odd ones. What did we put? What did we put at the top? It's positive or negative. Positive or negative. Okay. So if you're finding the odd root of a number, your answer is either going to be a positive number or a negative number. All right, this is where it gets confusing. I wouldn't even say confusing. It's just hard to keep track of. Okay, if n is even and a is greater than 0. If a number is greater than 0, what does that mean? It's positive. Okay, then what is going to be the case? A is going to have 2 real roots. And it's going to be a positive and a negative number. Okay. Positive and negative. Not or negative. So when it's odd, it's positive or negative, one or the other. When it's even, it's going to be both positive and negative. And we'll discuss that at length. Okay. If n is even and a equals 0, what's the root of that number then? What's the root of it? What's any root of 0? 0. Then a has one real root. And that root will be 0. Should have given me a little bit more space to write up there, but that's okay. Okay. If n is even, so I'm taking an even root of a number, and a is less than 0, what does that mean? A is less than 0. What does it mean about that number? It's negative. If a number is less than 0, that means it's negative. Okay. For the sake of this class, there are no real roots. Okay. there are ways for us to find roots of negative numbers like that, but it's more complicated, and we deal with that in algebra 2. Okay. All right. Let's do 2 numeric examples, okay? This is asking me for the what root of 27. With that little number there, what root of 27, negative 27 am I looking for? The what root? Third root, cube root, okay? So let's find the cube root of 27. So I take my sheet out. I'm going to scroll down the cubes until I find 27. And what's its root? 3. Okay, but now I'm taking the cube root of a negative number. So it's not just 3, it's going to be negative 3. Notice that this was odd and my answer is only negative 3. Well, why does this work? Pretty easy. Because negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. So that's why that works. Why is it not positive 3? Well, pretty easy. It's not positive 3 because 3 times 3 times 3, positive 27. So that's why it's only negative 3 here. Does that make sense to everybody? Okay. All right, so now what root of 625 am I looking for here? The fourth root of 625. So I'm going to take my sheet out. I'm going to scroll down the fourth powers until I find 625. And what's its root? 5. It is 5. But I'm taking an even root of a positive number. It's positive and negative 5. Okay, let's talk why. I'll start with the positive one. It's positive 5 because 5 times 5 times 5 times 5. Well, let's check. 1, 2, 3, 4, 625. And unlike the previous one, it is also negative 5 because 1, 2, 3, 4. So when you take an even root of a positive number, you are going to get plus and minus. You're going to get both the positive and negative version of the root. Where if you take the odd root of a negative number, you're only going to get negative. If you take the odd root of a positive number, you're only going to get a positive. Okay? That's the confusing part, quite literally. So are we good with that? Anything I can clarify? Okay. Ready? Let's just start by finding some roots. Okay? Everybody loves a good root. Okay, 1a, the what root of 1024? What root of 1024 am I looking for? Fifth root of 1024. So I'm going to go here. Here's 1024. The fifth root of it is 4. Okay, so yeah, it's kind of hard to see because I crammed so many numbers. Okay, now here's a question. Is it positive 4? Is it negative 4? Or is it positive and negative 4? Positive and negative. Anybody else think differently? What root am I taking? 5. Is that odd or even? Odd. That means it's either plus or minus, not both. Look, it's positive or negative. So mine would be just positive 4. Just positive 4. Okay, what about 1b? What root of 49 am I looking for? There's no number there. The square root or the second root. Second root of 49. So here I'm going to find 49. It's 7, and I'm taking the square root that's even, so it's positive and negative 7. Okay, because again, negative 7 times negative 7 is 49. 7 times 7 is 49. Okay, 1C. What root of negative 729 am I looking for? What root of, okay, we got the answer, but what root am I looking for? The third root. So I have to look at my third root or my third power column. 729, its root is 9. It's odd. So what's the answer? Negative 9. Only negative 9, not positive and negative. And what about 1D then? What's the answer to 1D?
There's no it's positive and negative, but it's
Okay, so this is kind of a little contradiction. This is no real roots. Okay, because one might think it's positive and negative 3, because you find your fourth root, go to 81, and you're going to think it's 3. But if it's 3, then that means I should be able to go 1, 2, 3, 4 and get negative 81. But I got positive 81. So then somebody might think it's 1, 2, 3, 4. But I got positive 81 again. This is an impossible problem to do. Okay, you cannot take the even root of a negative number. And you know what? I probably shouldn't say you cannot, because you actually can. But you get just literally called a complex number, and you will deal with that another time. You can do that. Just for the sake of this class, no, you can't. So if you come across an even root of a negative number, you're just going to have to communicate to me that there's no real root there. And I need you to put the real there, because there's real and complex. You just haven't dealt with complex yet. Okay. So make sure you really focus on, is it positive? Is it negative? Or is it positive and negative? Okay. Let's try monitoring progress 1 through 4 below. Okay. And then you can check it off with my answers here in a moment. All right. Brandon, what you got for 1? RJ, what you get for 1? What is it? 2. What do we get for 5? What do we get for 3?
no.
And 4. Positive and negative 6. Good. Hey, so we're good with finding roots? Okay. You guys dealt with roots before? I feel like you should have square roots at some point, middle school. A little bit. All right. Now what we're going to deal with is fractional exponents. Okay, exponents that are fractions. Okay, it sounds way worse than it is, because What I just explained on the front page, you already know about fractional exponents because they're the same thing. Okay, so rational exponent, let a to the 1 over n be the nth root of a, and n be a positive integer. Okay, if I want to take the 1 over n power of a, that is going to be the same as the nth root of a, which we just dealt with on the previous page. Okay, so what does that mean? That means if I have 16 to the 1/4 power, that is going to be the same as the what root of 16? The 4th root of 16. Okay, so the bottom of your fraction on an exponent, that is a fraction, that's your root. So if I want 16 to the 1/4 power, that means the 4th root of 16. And we should already know how to find the 4th root of 16 based on the front page. Okay, here is why that works. Imagine that I have let's say the 5th root of, actually, not the 5th root. Let's say I have 3 to the 5th power. Okay. If you use your chart to the side, 3 to the 5th power is just 243. Okay, so now what I'm going to do is I'm going to, off on the side, what I'm going to do is I'm going to take 243 to the 1/5 power. But instead of 243, what can I write that's equivalent to 243? Okay, you're right, but I'm talking only 243. What's something that's equal to 243 on the board here that I could rewrite 243 as? 3 to the 5th power. So here I'm going to write this as 3 to the 5th power to the 1/5 power. And I can do that because 243 is the same as 3 to the 5th power. What's happening right now is I'm doing a proof. Well, it's not really a proof, but it's pretty close. Hey, who remembers our exponent rules? What do I do here? Power to power, what do I do with my exponents? Multiply. What's 5 times 1/5? 1. So this is 3 to the 1st, which is just 3. So what does that mean? That means 243 to the 1/5 power is 3. Which means 243 to the 1/5 power is 3. So that those roots are the same. The roots are the same as those exponents. So that's technically why it works. Okay. Now, for the most part, realistically, what you're going to be asked to do is these problems, is like 2A. So this is our first learning target. Actually, what we did on the front page is not a learning target. It's part of it, but it's not actually anything new. So I can rewrite a rational expression as a root and then evaluate that number. Okay, so if I have 49 to the 1/2 power, I need to be able to write that as a root, and then I also need to be able to get that number. Okay, so Tyson, what is this? How would I rewrite this as a root? Brandon, how would I rewrite this as a root? RJ, how would I rewrite this as a root? I would maybe take the hint. Okay. The bottom of this fraction is 2. So this is the square root. This is the exact same thing as the square root of 49. If you want to put a little 2 here, you can. I'm just telling you, you're never going to see it written like that, Bill. Okay. And then, so that's 2 of your 4 points. The remaining 2 points, if you're talking about how I'm going to grade this, is just being able to tell me what the square root of 49 is. So what's the square root of 49? It is 7, but it's what? Is it plus and minus 7? Is it just 7? Just positive and negative because it's an even root. Okay, so that's what 4 points would look like. You're rewriting it as the root, okay, and then you're telling me what that number is. Okay, let's do 2b. 1/3, so negative 216 to the 1/3 power. That's the what root of negative 216? The third root of negative 216. Okay, here, negatives inside the parentheses. Since it's inside the parentheses, it goes inside the root. Okay, what's the cube root of negative 216? -6. Just -6 because it's odd. Okay, now in 2c, that's a little bit different because the negative sign is on the outside of there's no parentheses here, right? So it's inside the parentheses, it goes in the root. It's not inside parentheses, it does not go inside the root. Okay, so what is the fifth root of 7,776? 6, but I have this minus sign, so this is the opposite of the fifth root of 7,776. So then this is -6 because and I know they seem very, very much the same, but there are subtle differences there. So that's why I'm having you write both of them out so you can kind of show me that you know. 2d. Is that negative going to go inside my parentheses or outside my parentheses? Okay, it's inside the parentheses, so it goes inside the root. What root? The fourth root. And what is the fourth root of -625?
-5.
Not -5.
No real. It's no root.
It's no real. You can't take the even root of a negative number. Okay, so real quick, here's an example, and I should have done this in 2C. But if I had this, now all of a sudden you're going to get an answer because now you have the negative fourth root of positive 625, and you can find the positive root of 625. Okay. So that is just a subtle difference there in this. So kind of is more purposeful in 2D, but either way. Okay. Questions about 2A through 2D? All right. Try 5 through 8. We're almost done. Because 3A through 3D is it's going the reverse order. So go ahead, take a moment to try 5 through 8, and then we will progress to the last learning target. Things to look out for. This minus sign's outside the parentheses, so it's got to go outside of the root. Sorry, I froze this again. Negative's outside the parentheses, so it's got to go outside the root. You end up with -8 either way, but this is technically is correct, and you would lose points had you not been able to do that. Okay. Another thing to look out for is on 7, I am taking the even root of a positive number. So my answer is going to be positive and -5, because 5 times 5 is 25. -5 times -25, or -5 times -5 is also 25. Okay, 8, you are going to write it as the 4th root of -16, which is no real roots. So, because you can't take an even root of a negative number. Okay. So fraction exponents really, honestly, are not that bad. They look way worse than they actually are. Okay. Any questions about learning target 10? If you're good with 10, I have a hard time believing you're going to have any issues with 11, because it's the exact same thing. We're just reversing the direction. Okay. So now what we're going to do is your goal is to be able to rewrite a root as a rational expression, meaning a base and an exponent. I have to see that. And then you also have to tell me what number is it just equal to. Okay, so cube root of -512. What would my base be if I wanted to rewrite this as a base with an exponent?
-512.
1/3. Perfect. And spot on with the parentheses. The negative number is inside the root. So that negative sign needs to be inside that parentheses. And then what is -512 to the 1/3 power? What number is that equal to?
Wait, -8.
But I need to figure out, the evaluate means tell me what number is this actually equal to. So I'm going to take my sheet here. I'm going to go to 512 and find its root, which is -8. Okay, 3b. What's 3b? What's the base? What's the exponent? Where's my parentheses? Okay, this is going to be -100 in parentheses to the 1/2 power. And yes, this is going to be no real. For the sake of this class, you cannot take the even root of a negative number. What about 3c? 256 to the 1/4 power? And what is 256 to the 1/4 power? It's what? +4? Just +4? It's plus and minus. You take an even root of a positive number, it's going to be positive and -4. Okay, what about 3D? Okay, this is good. This one would come without parentheses because the negative sign is outside of the radical symbol. This is a radical symbol also. And then to the 1/5 power, because the 5th root and the 1/5 power are the same thing. And then all I have to do is determine what that number is. 4849, 48,049 in the 1/5. Oh yeah, this popped up in the other class. Now I know. Okay, my guess is this is a typo, but that doesn't mean we can't approximate what it's going to be. So we know that 4849 is not on here, right? But between what two perfect fifth powers is it in between? Okay, so it's in between the 8 and the 9, right? Because it's going to be in between 32,000 and 59,000. So is it a little closer to 32,768 or a little closer to 59,000? Okay, but it's fairly close to the middle, though, right? So what's a good approximate? Close to the middle, but a little closer to 9. 9.5 would be in between 9 and 10. 9 3/4 would also be between 9 and 10, and we know that this is going to be in between 9 and 8. 8.5, 8 3/4. For me, I'm thinking negative 8.6. It's pretty close to the middle, but it is slightly closer to, it is slightly closer to 9 than it would be to 8. Okay? I don't think that that's going to come up on a learning target on a test. I think this was probably a typo, but either way, you should still be able to problem solve to get an approximation. Although this does come up on the homework. Okay. Okay, 9, 10, 11, and 12, and then we're done for the day. Well, we're done with the lesson for today. Okay. So, real quick before you all go off and try to do your own thing, I'd like you just to do all the practice problems. It's not really that much, and the problems go very quick. Okay, 5 through 6, 13 through 18. Okay, at that point, once you get those done, if you need me to look at those and check, give you a little feedback, that's fine. But otherwise, I think you're going to have 2 problems of learning target 11 and 2 problems of learning target 10. And then and everybody should get that done today. If you're not getting that done, I really feel like you're wasting too much time. Okay, I bet you some people could probably even get done before the lunch session. Okay, otherwise that's it.